Hi, everyone. Welcome to Chapter 1 of Physical Geology. I'd like to start the semester off looking at this sweet picture of the most dangerous volcano in the United States. Do you know where this is? No? Maybe? It's in Washington State, and it is a national park, and it is Mount Rainier National Park, and this is Mount Rainier, which is considered to be a dormant volcano. And the reason that it is the most dangerous volcano in the United States has to do with all of this at the summit. So these are about 20 glaciers and snowpack total. And when this volcano erupts, I think you can figure out what happens to a lot of this snow and ice, right? It melts and it mixes with volcanic ash and it rushes down the slopes of Mount Rainier in what are called lahars. We'll learn about that later this semester. And lahars basically wipe out lots of villages and cities that are located along river valleys. And in this case, Mount Rainier is just upslope of Tacoma, Washington, which is a very large city. And actually, if you drill down into the bedrock below Tacoma, Washington, you find layer after layer of volcanic mud flow, which tells you that when Rainier erupts, that's exactly where it goes. So Mount Rainier is a fantastic place, even though some people find it a little scary. Rainier hasn't erupted in several hundred years, but it's one of many things that we're going to learn about this semester as we start to tackle geology. So geology is a fascinating topic. I ended up in geology very sort of randomly. I really liked earth science in high school, and it turned out that I really like puzzles and I really like traveling, and geology lets me do all of those things. Geology is the study of the earth. It's the scientific study of the earth. It's where we take our observations and we take our critical thinking and analysis, and we learn about the surface of the earth, the interior of the earth. And like all science, geologists study the earth so that we can better understand the earth that we live on, and so that we can make the world better for people and for the environment that we live in. So anyway, it's a fantastic topic. Like all big topics, you can subdivide it, and geology is no different. And you can subdivide geology into two big branches. So this is another picture, by the way, of Mount Rainier. This was taken in July, so you can see that during the summer months, it's still covered in snow largely, and these are some beautiful little lupins on the flanks of the mountain. And I think this is a great way to think about physical geology. Physical geology is the study of today. It is the study of the earth materials that we see. That includes rocks and minerals, which is a lot of what we do at the beginning of physical geology. It includes a lot of the surface processes that occur on the earth. So that includes things like weathering, mass wasting, rivers, glaciers, groundwater to some extent, as well as the interior of the earth. So a lot of what goes on in the interior of the earth has ramifications for people who live on the surface, like volcanoes, for example, or earthquakes. So geologists who are physical geologists, study what is happening today. We record information today so that we can, again, make the human experience better. So this is a sweet picture of a Tyrannosaurus Rex skeleton, or cast really, from Wyoming. This picture is taken actually in the cafeteria of Western Wyoming Community College. Wyoming has a really rich dinosaur collection, and so I thought it'd be a cool way to illustrate historical geology, which is the other major branch of geology. So geology programs across the world are set up similarly, where students generally take physical geology first and historical geology second, and you'll be able to see why. So once we understand all the things from physical geology, like how the earth works today, how we can understand it today, we can then take that information and apply it to the ancient record. So the earth has changed a lot. The earth is about 4.6 to 4.5 billion years old. It's really old. And by studying the rock record, we can figure out how the earth has changed over that 4.5 billion years. And it is tricky, but it is fascinating. So what sort of things do you think have changed over time? Like Like lots of things, like mostly everything. Usually students, when I ask this question, will come up with life. Life has changed over time. Life has evolved from being singular celled organisms to multicellular organisms. When you think about the diversity of life on our planet, it's kind of staggering. And some things are alive today, but it turns out that over 90% of everything that's ever evolved, according to the fossil record, has gone extinct. So life has changed dramatically in response to other changes on the surface of the Earth as well. Geography has changed over time. There are times when, so MCC is located in Rochester, New York, which is pretty cold a lot of the time, but Rochester, New York used to be located near the equator. We have fossils here of tropical organisms. It hasn't always been this way. So the makeup of continents, the location, the size of continents, all of this has changed over time. So I teach both physical and historical geology. Historical, I just find to be just a fascinating class because of how we can tease out some of these changes in life and in geography and in chemistry of the Earth. So when I say chemistry of the Earth, I mean all different aspects of the Earth's atmosphere. The composition of the Earth's oceans has changed over time, and even the composition of the soil has changed over time and is a response to changes in the atmosphere and oceans. There are time periods when there seem to be different metals that were more common in the oceans than there are today. There were times when there was no oxygen in the atmosphere. And so by understanding how we can examine the rock record, we can figure out a lot of how the Earth system works. Part of that is understanding how it works today so we can predict how the Earth will change and impact people in the future as well, and where we can begin to look for important resources that we rely on as part of our modern day life. Cool. So the history of the Earth can be summarized in a document called the Geologic Timescale. And I'm going to give you a really brief overview of this. When I teach historical geology, it feels like we spend 15 weeks kind of unpacking this. And so this is just not even the tip of the iceberg. The Geologic Timescale summarizes the history of the Earth, all 4.6 to 4.5 billion years of it. And I'm just going to really briefly talk to you about the history of the Earth. So this is a really small block right here, but this actually represents 85% of all of Earth history. It starts about when Earth first cools about 4.5 billion years ago, and it goes up to about 500 million years ago. This time period is collectively called the Precambrian because it occurs before a time called the Cambrian, when most life on Earth was single-celled organisms, and it's not till just before the end of this era, this eon called the Proterozoic, that multicellular organisms really show up. But this is a fascinating time. This is a time when the oceans form, when the continents form, when continents grow. Many people have heard of Pangaea, which is the most recent supercontinent, but there are multiple supercontinents that existed during this period of time. But by the time that these three eons, the Hadean, the Archean, and the Proterozoic end, Earth is pretty much set up the way it is today. There's oxygen in the atmosphere, there's life on Earth, and the next eon is, you'll see part of it here, it's called the Phanerozoic. The Phanerozoic we can break down into three different eras, and the first is called the Paleozoic. Paleozoic literally translates to ancient, which is paleo, and zoic, which is life, so ancient life. And what you see is that during the Paleozoic era, most life, though not all of it, was restricted to the oceans. So you have what's called the age of invertebrates. Perhaps you've heard that word before. Invertebrates are organisms that don't have backbones, and initially most organisms that live on Earth are very relatively simple organisms without backbones. If you live in New York, you have maybe seen that we have like amazing fossil collections of fish. And that's because a lot of the rocks in New York State were deposited during what's known as the Age of Fishes. So this is a time period when fish get much larger, they get much more diverse in the oceans. And eventually, at the end of the Phanerozoic, or the end of the Paleozoic, the age of amphibians begins. This is a time period when organisms begin to invade the land, and we see fossils for the first time in rocks that are deposited on continents. Something crazy happens at the end of the Paleozoic. There is a massive mass extinction where it's estimated that somewhere between 95 and 97% of everything that is alive goes extinct in about 1 million years. Geologists often refer to this period as the Great Dying. When this extinction occurs, life on Earth looks incredibly different afterwards. Whoops, I went the wrong way. There we go. At the end of this extinction, there's a whole new era on Earth that's referred to as the Mesozoic, which means middle life. And this is something that probably most of you have heard about. This is called the Age of Reptiles. During this time period, there are 3 geologic periods that occur: the Triassic, the Jurassic, and the Cretaceous. During this time period, dinosaurs are the dominant life form, and we see the first birds and flowering plants appear in the fossil record. Luckily for humans, the age of reptiles comes to a rather abrupt end around 65 million years ago. During this time, a large comet hit the Earth and resulted in a lot of devastation. It resulted in the Earth being dark for months, global wildfires, massive earthquakes, and pretty much a crashing of photosynthesis. About 70% of everything that is alive goes extinct. Luckily for us, mammals are not one of those groups of organisms, because mammals become the dominant life form on Earth in part because there was this mass extinction at the end of the Age of Reptiles. So we currently live in what's called the Cenozoic era, which means modern life. And it's, again, referred to very often as the Age of Mammals. During this time period, mammals take over every niche in ecology. We occupy everything now. And again, I just think it's so cool that part of the reason that happens is because a giant icy rock fell out of the sky one day that led to us being here today. So I want to remind you here that the Earth is 4.5 to 4.6 billion years old. That will 100% be on your first test. It will probably be on your final exam. So put a star in your notes or however you're keeping track of things, because that is an important point.